Now, let's talk about laws of exponents for division. So, for you to solve division of polynomials, you have to know the basic rules or simply the laws of exponents, okay? So, our essential question is, why is it important to understand the laws of exponents? Okay, laws means it is really important. In what way? For us to solve problems, specifically division or multiplication, as well as the other operations. So let us observe the following. So as you can see, 3 to the 6th power divided by 3 squared is equal to 3 to the 4th power. A to the 5th power divided by a cubed is equal to a squared. Okay, so x to the 7th power divided by x to the 4th power is equal to x cubed. Now, what have you noticed on these expressions? The expressions above applies the first law of exponent for division. So it says that a to the m power divided by a to the n power if m is greater than n, okay, or if the exponent of the numerator is greater than the exponent of the denominator, which is n, you have to subtract them, okay? So our base is a whole number, then subtract the exponent, okay? M minus n. Again, okay, knowing that the base or the bases of the given, the numerator and the denominator, are the same, you have to take a look at their exponents. If the exponent of the numerator is greater than the exponent of the denominator, therefore, copy the base or the same base, that is a, then subtract their exponents. So, m minus n. Therefore, our answer is a to the m minus n power. So, simplify the following. X to the 4th power divided by x cubed. As you can see, we have the same base. We have x. Then, our exponent, 4 is greater than 3. Therefore, 4 minus 3. Then simplify, x raised to 4 minus 3 is x raised to 1. In that case, we don't need to write 1. So, the answer is x. Okay, that is understandable that the exponent is 1. How about 4 raised to 8 divided by 4 raised to 6? Okay, so we have the same base, that is 4. Then the exponent of the numerator is greater than the exponent of the denominator. So 8 minus 6. Therefore, we have 4 raised to 8 minus 6 power. And the answer is 4 squared. And when we compute that, 4 squared is the same as 4 times 4, which is 16. Okay? That is the first law. Okay? Same base wherein the exponent of the numerator is greater than the exponent of the denominator. Therefore, the answer is whole number wherein you have to subtract the exponents. Okay? So let's observe these expressions. 4 squared divided by 4 to the 7th power. That is equal to 1 over 4 to the 5th power. X cubed divided by x to the 5th power is equal to 1 over x squared. A divided by a to the 4th power is equal to 1 over a cubed. Now, what have you noticed? In that case, we use the second law of exponent for division, which states that knowing that the expression has the same base, what are you going to do is to subtract the exponents. But you have to take note that m is less than n, okay? So on our second law, if the exponent of the numerator is less than the exponent of the denominator, therefore your answer should be in this form: 1 over a raised to n minus m. What have you noticed? As you can see, our answer for the second law is in fraction form. Okay? Wherein the numerator is 1. So in this case, we have 1 over, copy the base, then what are you going to do to their exponents? Copy n minus m, since n is greater than m. Now, let us simplify the following: y raised to the 6th power divided by y to the 8th power. As you can see, the exponent of the denominator is greater than the exponent of the numerator. In that case, okay, so our answer is on this format, in fraction form, wherein the numerator is 1, then the denominator is, copy the base, then raise to the higher exponent, which is 8, minus the lower exponent, which is 6. So simplify, y raised to the 8 minus 6 power, that is y squared. So our answer is 1 over y squared. Okay? Okay, let's try this. 3 to the 7th power divided by 3 to the 10th power. So, on this format, we have 1 over 3, our base, raised to the higher exponent, 10, minus the lower exponent, 7. So, 10 minus 7 is 3. Therefore, this is 3 cubed. Okay, that's why we have 1 over 3 cubed. And when we simplify that, 3 cubed is the same as 3 times 3 times 3, that is 27. Our answer is 1 over 27. Now, let's observe the following expressions. 5 cubed divided by 5 cubed, that is equal to 1. X to the 4th divided by x to the 4th, that is equal to 1. A to the 10th power divided by a to the 10th power, that is equal to 1. What have you noticed? The expressions have the same bases, and they also have the same exponents. In that case, your answer should be equal to 1. Okay? Let's see. The third law of exponent for division. So, having this format, a raised to m divided by a raised to n, if m is equal to n or their exponents are the same, as I said, your answer should be equal to 1. Okay? Automatic. Like for example, let's simplify the following. X cubed divided by x cubed. So, same base and same exponents. Therefore, the answer is equal to 1. 12 raised to the 9th power divided by 12 raised to the 9th power. So, same exponents we have equal to 1. Okay? That's it. Now, let's make a connection. Given x to the 5th power divided by x to the 9th power, so applying the first law of exponents for quotient, we have the exponent of the numerator minus the exponent of the denominator, which is x raised to the 5th minus 9th power, that is x raised to the negative 4th power. Okay, because 5 minus 9 is negative 4. On the other hand, applying the second law of exponents for quotient, so we can see that the exponent of the denominator is greater than the exponent of the numerator. In that case, when we apply the second law, The answer should be in fraction form. Okay? So let's see. Fraction form, 1 over, copy the base, x, then subtract higher exponent minus lower exponent. In that case, our answer is 1 over x to the fourth power. Now, what is their connections? Okay, what do you think is the connection of these two results? Okay, so x raised to the negative fourth power and 1 over x to the fourth power. What do you think is the symbol between them, between the two results? That's right. The two results are equal. You have to take note that x raised to the negative fourth power, wherein we apply the first law, is equal to 1 over x to the fourth power, wherein we applied the second law of exponents. Okay? But here, the exponent of the numerator is less than the exponent of the denominator. The proper law to be applied is the second law. Okay? Therefore, the proper answer should be 1 over x to the fourth power. In that case, if you see an expression with negative exponent, like negative 4, x raised to the negative fourth power, you have to convert it to positive. So as you can see, we have negative 4 here, and I converted it, or if we convert it to positive, we will be having this expression. Okay, 1 over x to the fourth power. How is that possible? Let's have the definition of a negative exponent. So if your exponent is negative, like this, a raised to the negative n, what are you going to do is convert it to positive by getting the reciprocal of the base. As you can see, the reciprocal of a is 1 over a, right? 1 over a. Since a is a whole number, automatic its denominator is equal to 1. So when we reciprocal it, we will interchange the numerator and the denominator. Therefore, we have 1 over a. Then copy the exponent with positive sign. Okay, like this. Again, a over 1 has a reciprocal of 1 over a. Then copy the exponent with positive sign. So 1 over a raised to n. Like on our results, we have x raised to the negative fourth power. Okay, so the reciprocal of x is 1 over x. Okay, 1 over x. Then we copied the exponent with positive sign. So 1 over x to the fourth power. Okay? So let's make another connection. As you can see, we have x to the fifth power divided by x to the fifth power. In this case, as I said, if you apply the third law, automatic your answer should be equal to 1. So applying the third law, we have equal to 1. That's it. But if we apply the first law, wherein you have to subtract the exponent, like this, so x to the fifth power divided by x to the fifth power, get the base and subtract the exponents. So x raised to the fifth power minus to the fifth power. So when we subtract them, the answer is 0. Now, what is the connection of the results? What is the connection of x raised to 0 and 1? What do you think? Very good. They are also equal. Okay? It means that x raised to 0 is equal to 1. So let's have the definition of 0 exponent. You have to take note that if the exponent of the base is a 0, automatic that is equal to 1. Again, if you see a 0 exponent, automatic that is equal to 1. For example, 2 raised to 0. Okay, 2 raised to 0, the exponent is 0. Automatic, the answer is equal to 1. If you input to your calculator any number with 0 as exponent, the answer is equal to 1. So 2020 raised to 0, that is equal to 1. Or 2020 raised to 0, that is equal to 1. Okay, any number, any variable raised to 0, that is automatic equals to 1. Raising a quotient to a power, it means that the operation on the expression is division. Like for example, x to the 9th power divided by 12 squared. As you can see, there is an exponent outside the parentheses. What are you going to do? Raising a quotient to a power. In that case, you have to distribute the exponent, or you have to multiply the exponent outside the parentheses to the exponent inside the parentheses, to the numerator and to the denominator. So let's start with the numerator. As you can see, we have x to the 9th power. What are you going to do is to multiply this squared, or the exponent outside the parentheses, to 9. So 2 times 9 is 18. Therefore, the answer is x raised to the 18th power. Okay? Now, if we do that on the numerator, we also have to do that on the denominator. So what is the exponent of 12? There is no visible exponent, therefore that is automatic 1. So the exponent of 12 is 1, so 1 times 2 is 2. Therefore, the exponent now of 12 is 2. So if we simplify this, the answer is x raised to the 18th power divided by 144, because 12 squared is 12 times 12, that is 144. Okay? Again, raising a quotient to a power, you have to distribute or multiply the exponent outside the parentheses to the exponent or exponents inside the parentheses. Number 2, 3y squared divided by 7 cubed. In this case, let's apply the quotient to a power. Take a look at the numerator, 3y squared. So let's start with 3. What is the exponent of 3? The exponent of 3 is 1, because there is no visible exponent, that is automatic 1. So 1 times 3 is 3. Now the exponent of 3 is 3. So what is the exponent of y? That is squared, or 2. So 3 times 2 is 6. Now the exponent of y is 6. That's why we have 3 cubed times y to the 6th power. Now, on the denominator, we have 7. What is the exponent of 7? That is 1. So 3 times 1 is 3. Therefore, the exponent of 7 is 3, or 7 cubed. Now, let us simplify. 3 cubed is equal to 27, then times y to the 6th power, divided by 7 cubed, that is 343. Okay, 7 times 7 times 7 is 343. Therefore, our answer is 27 y to the 6th power divided by 343. Okay, so it means that if the operation of the given expression is division and there is an exponent outside the parentheses, what are you going to do is to distribute the exponent on the numerator and on the denominator. That's why we have a raised to n divided by b raised to n. Okay, let's try the following. So I'll give you time to answer this on a piece of paper. Then later on, I will reveal the answer. I will dictate the correct answer. For number 1, the correct answer is c to the 4th power. For number 2 is 1 over 16. 1 over 16. For number 3, that is equal to 1. For number 4, the answer is 1 over 27. For number 5, that is equal to 1. For number 6, that is equal to 1 over 64. For number 7, the correct answer is 8 over x squared. 8 over x squared because negative 2 is the exponent of x. Therefore, we have to put x to the denominator, okay, to obtain the positive exponent, which is squared. That's why our answer for number 7 is 8 over x squared. That is in fraction form. And for number 8, we have x to the 6th power times y squared times z to the 8th power divided by 25. Okay, division of polynomial by monomials. So let's have this example. For us to easily solve this, you have to arrange them properly, wherein the first term should be the term with the highest exponent. Okay? So in this case, on our numerator, 8x to the 5th power has the highest exponent. Then followed by 6x cubed. After that is negative 20x. Okay? So let's arrange them. We have 8x to the 5th plus 6x cubed minus 20x, then divided by 2x. Since we can divide all the terms on the given denominator and we can divide the variable, let's divide them one by one. So let's start with 8x to the 5th power divided by 2x, followed by positive or plus 6x cubed divided by 2x, then minus 20x divided by 2x. Okay? Then let's simplify. 8 divide 2 is 4. Then subtract the exponent of x. 5 minus 1 is 4. So we will be having 4x to the 4th power. Okay? 8 divide 2 is 4. Then copy the variable x. Then subtract 5 minus 1 is 4. Next, we have 6 divide 2 is 3. Copy the variable x. 3 minus 1 is 2. That's why we have 3x squared. So, minus 20 divide 2 is 10. Okay? Then, what is the exponent of x? 1. What is the exponent of x? 1. In that case, they have the same exponent. Therefore, that is equal to 1. Okay? 10 times 1 is 10. That's why here we have 10 only. Okay? For this division, our answer is 4 times x to the 4th power plus 3 times x squared minus 10. Kindly try the following. Write your answer on your notebook. Just do the same process as I did so that you will be able to get the correct answer. Okay?
That's all for today. Thank you so much and God bless everyone.